Hi friends, welcome to Tech ARK IT YouTube channel. My name is Ravi. In this video session, we are going to see that what is Git and GitHub, how you can basically use the Git to develop your code and working on the version control system or the source control management, like the source code management, how you can do that. So basically, if you do not have the Git, what problems you will get. If you have the Git, what problems it solves. So why you have to use the version control systems in order to work in the development environment. So that's we are going to see in this course. And these codes from beginners who does not know anything about the Git to until the intermediate level. So who are looking for the advanced level of the Gits, though this is not for them. Because some of the most advanced is not covered in this code. So this is until to a beginner to an intermediate to a little bit advanced, but not a completely advanced layer of it. Okay, so do understand that and do follow with this along with this video so that you can get practice and create your GitHub account. Example, if I'm working without a Git, so what I do is that I just created a code file one. So just I'm starting as a coding. Maybe I'm developing some website. Then I make some file which I'm making the a page for the web server. Then so one day I worked it and added some code and then save that file. Then sometime again, maybe tomorrow or day after tomorrow, I wanted to work on the same file. So what I did is that the first code is working fine. I don't want to disturb that, so I make that code one file as a copy of it, and I started working on the file two. So now, as of now, I have the code file one and code file two, and again I'm working on next day maybe the code file 2 is working fine, then I created code file 2b. Then it goes on like example. So certain times you develop some code, it is working fine, you don't want it to disturb. So there is a saying that if the code is working, do not disturb, right? Something like that. So if the in development understanding, if the code is working fine, then do not modify it. So something like that. So what I do is that I make some files. Then I got to the conclusion that so these are all the development work which is coming to the final. Then I make a code final file. Then, so after making the even code final, I got something. Okay, there might be improvement on the code. There might be some fixes I need to make or anything. Then after that, again I have made one more thing, that code final too. If you see that there is, if you're making on the file, so there are a lot many files. So if you are working on a single project, but you are making 6 to 7 files to make one feature available on that system, then think that if you're working on a multiple projects, or if you're working for the multiple features, then how many files you make. So after making so many files on the desktop or in the folder, it makes a lot of clutter, right? That makes no sense. And again, so many things you made, file 2, file 3, file 4, file 6, and this feature is that feature. Then later point of time, if you want to revisit the code, then you have to open lot of files. So this file is for this file is for this, and all this stuff. Then get confused. For now it is okay, this is clean and you can just able to see this file is this file is this. But later on you work on so many developments, so many features, so many applications, then you make lot of clutter, right? So then you cannot understand which file is what file is what, all this stuff. To understand, then you make this problem clearly, like I want to solve this problem, I don't want to make lot of files and lot of codes, all this stuff. So what you can do is that you can go to the Git. So in the Git, what you can do is simply make a one file, and example that index.html file. Then you commit the content on the file, and today you worked it and you commit that content, and tomorrow come and again make the changes to the same file and commit, and something like that. You daily make small progresses and commit. So then end of the day, so your all commits are completed, you can push to the your remote repository. Your code is completely saved on the remote place. Then whenever you want, you can just pull that file and revisit that file. If you want to modifications, you can do the modifications on the same file itself. So that makes a lot of sense. But if you make a lot of files here, that does not make sense. Like so many files and so many things, you have to go here, there, changes here, changes there, something like that, right? But Git makes simple is that you can create only a single file where you are working on the single code. Then you can make a lot of files, maybe like one feature one file or some supporting files to that. Then you can write the code over there and commit that. So it's a single application or the single feature or the single few or files which are you are really working on, which are required on the application, will be there. But you don't need to make a lot of files to lot of clutter while working the on the developments. That makes simpler your work on the Git. Let's see what exactly Git do and what its purpose. So Git was created by Linus Torvalds, the founder of the Linux operating system in April 2005. It was designed to address several key problems like challenges that software developer faced existing version control systems. After the 2005, so there is a growing community. A lot of people are contributing to that. This is Git is actually released as a public to the an open source project, and quickly gained a lot of attention and speed up and distributed across the multiple contributors joined and did so many contributions. Then it's growing community from 2005 to 2008, like it's grown a lot of bigger. Then after that they introduced the GitHub. So Git is basically a command line tool or the core tool where it does not really have the direct storage, but GitHub has a feature that it can enable the GUI based interface, like the browser based interface, which also have the storaging feature, like you can store some files on the GitHub, all the stuff. Then the GitHub makes a lot of features to like publicly available repositories, then code collaborations, all this stuff. And that's how Git went to the popularities in 2010, and Git made like enterprise features on 2010, and Git 2.2 is 2.0 is released on 2013. Then now you can see GitHub, a large repository where so many open source projects are on GitHub, where you can create your own GitHub account, and even you can prepare your repositories and commit the code and do the software development, right? So it's important to note that the Git development is ongoing, right, with a regular updates and contributions to the global community of the developers. So it's ever changing updates and ever changing features. It's completely new things. There are so many collaborative options are coming and practices across the world. So that's the so
Git
what is the
example.
problems basically with the previous versions of the code before the Git, and how it is basically trying to solve that issues, right? Let's see here. So before that, if you see the collaboration tools before the Git, this was on a centralized repository models. Centralized repository means like single centralized repository you have. That's where you commit all the code from your systems, laptops, desktops to the central code. And whenever you want, what you can say, example, you have some 4 or 5 developers working on the central repository. So what you can do is that you can just do the commit the data to the central repository. Then the code will go and commit to the central repository, and what you can do, you can just the update. Example, user one is committed some comments or the some code updates, and user 2 is committed some code or committed some code, developed some code and committed. Then user 3 also did same, and user 4 also do some code and update it, right? Then after committing all of this, what you can do, so if you want to see the other user what he's developed or what is the content, the code of the content, the information about the code and the code, you can do the updates, then it will synchronize to your local laptop or the desktop or machine where you are working from. So that's how you get the data. But think here, so you are completely dependent on central repository where your repositories are, and you have to have that central repository available at all the time. Example, if your central repository is down for a few hours, then you cannot really do anything because you cannot develop the code on local repository and do the commit because it's a central synchronization. Wherever, if your central repository's access is slow, so then you will get the slower performance, and if at all a central server is failed, then you get the data loss or something like that. And consistently require the coordination with the centralized server, leading to the potential bottlenecks. Like example, you have to have the central repository available all the times. Server like maintains the version history, and wherever you do that. So okay, this initial perspective, that would be a good, like instead of making a files, multiple files, you can just do the file and update the code, and it saves on the central repository. You can commit it and you can do the reverse update, then you get the data on your local repository. Okay, that's absolutely fine for the traditional development workflows, all this that, but it has a so many bottlenecks here, like you're not able to do your work whenever the repository is down, or if the repository is bigger, then update takes a lot of time to do that. So until that, you have to wait for your code writing mechanism, right? Limited branching and merging capabilities all together. This is about the centralized repository. This where there are some bottlenecks and the problems they identified, they wanted to resolve it on a featured repository mechanism. So that's where it's changed into a different methodology called as a distributed repository. So how the distributed repositories make? So distributed repository has, each user has their own local repository, like it's less dependence on the network. So even the user can work on their own offline mechanism, like if the repository is cut off, then still they have the local repository, and they can work on offline. If they don't have the internet connectivity, still fine, they can develop the code. Once they wanted to push the code, they can connect to the internet and push it to the central place where the central repository is located. So that way, faster operations, most tasks are local. You can do the most operations to that location, right? It's much faster. So enables the parallel development environment. So what do is that they basically initialize the local repository, and there itself they add this code to that local repository and commit to the local repository itself. Day by day they do the development. Once the feature is developed and they say that okay, this is the time I can push this to the central place, then what you can do, from local repository they can push it to the central repository, and that's where all the developer can collaborate it. But here there is a thumb rule that always in the development, you have to make a small changes to the repository at the same time. So you don't need to wait for a at least a 1 week or 10 days to commit the code, then do the commits. Right, by the time the feature might be have developed or changed a lot, and the code has been changed, then you have to pull it back and reverse push it. So that way, what you develop today are then immediately may commit to the local repository and push it to the remote repository. Then other people can pull that repository and do their development. So that way, it's easy to develop and small changes, and easy to remediate. That's the easy. I'd say highly scalable workload is distributed among the users, so that makes more parallel development easy. right? Adaptable to the various development workflows and more suitable for modern agile practices as well as the DevOps models. So that's a difference, major difference between the a distributed repository and central repository. So central repository, the example, if I can give you that a SVN is a central based repository like a centralized source control system. But if you go within a latest versions of the Git and GitHub, those are basically are mercurial, also gained popularity, has a flexibility and performance and distributed repository mechanism. So that's basically how they wanted to resolve these issues between the a central repository and distributed repository here. To do this practice on your Windows machine, on your Linux machine or Mac machine, okay, let's go jump into the practical and how getting started with the Git and Git commands to the basics. Then how we can do this all committing the database, how the workflow works, and how we can log into the GitHub and create your account and push your code and collaborate with others and contribute to these open source communities and make your name over there, right? Let's jump into the practical. Here I am in Debian Ubuntu version, Ubuntu 22.04 LTS. How to install a Git here? So before that, you just check that if you see that Git command not found can be installed with get install Git. Then what you have to do is that first of all, sudo run apt-get update, so that this will update your cache of the repositories. It will refresh your repository with the latest information on the cache. It will update the cache. After that, what you can do is that you can just run sudo apt-get install git all. So this is the you require to install, which will install all the dependent packages for the Git. So that's what you have to do. Wait for a minute so that it will download and install all the packages. After that, you can check whether the Git is installed or not. So that's the thing you can do. Then you can confirm that the Git is installed. So it's almost completed. Now you can see it's completed the command. Now you can just type git. If you see the git options, so that is the one way you can confirm that your git command is installed. Or git version is the one you can say that okay, git version 2.34.1, which is the version which is already installed on your Ubuntu machine. So in other case, it's just simple that git command installation on the Linux or the just Ubuntu version. If you want to install on a Fedora, Red Hat Linux or CentOS, where you can use the different commands. Okay, so in case of Windows, how we can install the Git? Let's see that. So here I'm in my Windows machine. So let's say Git Bash download, then so it goes to the git-scm.com/downloads. Click on that link. Then so which version you want, so you can just, it will automatically detect the latest version. You can say download for Windows, then which version you want, so which one, standalone installer or a portable version of it. So we just go with the standalone 64-bit. Let's select that one and download that package. So now your Git 2.4.0.2 64-bit is downloading. So once you download, so you simply need to run this package.exe package, so we can run through the installation steps here. So let's I just click on that software, so it will execute for the installation. So you can see that now, so it is try to install the Windows here, so GNU General Public License, right? So now just say next, and which is the default path program files where the it is going to install. Let's keep it default. So you want anything here, so you can just say additional icon on the desktop, so it will be easy for you to do that. So if you want any daily updates on the Git, so you can just click this one, so it will just check for the daily updates. If any new update, it's automatically install that update. Okay, and then click next, and the Git is the one version where you can select. And here, so you have to select the which one is your default Git editor. So if you already have Notepad++ or Visual Studio Code, you can select any of that one. So it can just open that Git files with these things. So let's say I have Visual Studio Code for the Git as a default editor. I select that one. Next, and so here, example, before that, Git Bash was written. So there was a master is a default branch for that for all the Git and GitHub, but now it is changed to main. So here, what you have to do, just say override the main default branch name, instead of master, you make a main. That's the change you need to do, and click next. And here, so which one you want? So you want to use Git from the bash only, or Git from the command line, as well as from the third party, and Git optional Unix tools you want. You can just say find commands and all this stuff. Let's say make this default for that one, or you can also use this one. Anything is okay. So I can select this one, command line option, and say use bundled OpenSSH, or you can also use .NET spelling option, or external OpenSSH. You can also use anything. So go with the bundled option, which is the default option, and go with the default OpenSSH library. We don't have any external certificate. Check out Windows style commit, Unix style line ending. So that's what we need. Then you can use the min.tty. So these are all just a default option. Just next, and you can see that this is the one thing where which is actually install your credential manager, Git credential manager, to cross-platform access. So that's the Windows Bash advantage. What you can do is that while integrating with your Git Bash or the Git, so you can use this credential manager to store your access key, so that every time you want to do the commit or pull, then it will not ask you the password again and again. So that's the advantage. You can make it using this credential manager. Let's install that. Enable the system caching is recommended. That's all the options. Click next, and it will take a few minutes to install this one and dump all the DLLs and .exe files on the required locations. Then your Git Bash would be ready. Let's wait for a minute. It would be ready in. That's all. Post installation, you can see the release notes, or you can launch Git Bash. So click on Git Bash, just finish it. So it will launch the Git Bash here. Now you can use the Git version to check your Git version. So you can see that now Git version 2.4.0 Windows 2.2 is has been installed on this one. So that's what we need for the installation. You don't need any additional tool to install here as of now. That's all. Let's jump into the actual session and how you can create your GitHub account and create the repositories here. Okay, so now what I'm going to do is that I'm just opening my browser and go into the github.com. So github.com. So click on the sign up button here, which will go here and say welcome to GitHub Adventurous, and now provide your email address, right? Where my email address, which is one I'm providing here, and click continue. So now it says you to create your passwords. Okay, be careful while creating. It should be a capital letter, small letters, and numbers. It should be a more complicated one, right? Then you can make. So I made one a password, which should be strong enough. Now enter your username. So which is your username for your GitHub? Make any username that should be a most easy to understand or easy to call. Maybe I say code base. Um, that's the one which is not available here. Code base. Ravi, something like that. So add it. Maybe I can make something like dash here, so that would be easy for me to understand code base Ravi. You would like to receive the product updates via email or not? If you say yes, you can receive that one. Maybe I say why, so that I want to receive some updates on my email address, what's going on the here, and you can say verify your email account. So for what you have to do is that you so it's a complicated verification. It's completed. Now say create your account, and it will send you the confirmation email to your email address. So then you have to enter that one as a launch code so that it can verify you are a correct user making the correct email address, right? So who is going to use your account? So whether you have some developers or no. So let's say I'm just 2 to 4 people are going to utilize this one, and say I'm an a teacher, something like that, and continue. And do you want any of these tool to be installed? As of now, I don't want. Just say go continue as a plain GitHub repository. I don't want any new things here. I just say free is required for me. Just say select the free one. I don't want any new features or new tools to be integrated. It's initializing your repository. So this is your page here, first page, where you want to create your um, repository here. So let's make one repository for us to develop something. So this I'm going to make some public repository as my first one. So here code base Ravi, so my start repository, or you can also say create repository here, and make your repository name example, say my web app. Okay, so my web as is my repository name. So I'm going to give some description to this one. What is this one? So I am developing a web website for students who can access and learn through it. Right, this just a description about that repository. So if you want to add the initialize the repository admin, that would be a more easy for that add the readme, then you can write the more details on that readme profile. So by default you can see gitignore is created, and choose the license is GPL1, and say this is going to be set main as your default branching, then say create repository. So that's what we need for a default one. You can see that, right? So your repository is created successfully. Now there are some all these options as of now: issues, pull request, actions, projects, so many things. We don't want to go and confuse right now. Just stick on the code base right now of code repository. So my repository is created successfully on GitHub, but I wanted to make this on my local repository and work on it. How you can do that? So I have 2 3 accounts to collaborate, and how we can work on together to the multiple accounts and make the changes, right? Let's see that how you can do that. So if you work from the Windows, or if you work from the Linux or anywhere, the Git commands are same. So it can work from anywhere. So what I'm doing right now is that I'm just committing this, doing makes some clones from the repository here. Okay, so how you can do that? So basically, in order to do clone your repository, so you can simply make this one like git clone, and paste your URL. So the URL should be copied from the location of your Git repository you have created. So this is my Git repository. You can click on this green dot here, code, and copy this one, right? So it is a HTTPS, SSH protocol, and GitHub CLI. So either ways you can use any of this one, but as of now a preferred way could be a HTTPS or SSH. You can use any of that one, but making SSH should be like you have to add the keys. So how you can add that keys, I will make you aware of how you can add that into your account. Okay. As of now, don't worry about that and make this clone, right? So open your Git Bash or Linux, anything, so you can make your clone. So git clone and paste your URL here. Then it enter. So it will basically make your cloning. Then if you just type here ls, then it will show all the directories. But as of now, my web app is my repository. I just cloned it. Now you can just type ls-la. This is my readme file, right? If you say notepad rvi something like that, then readme file, if you open this one, you can see that this is my repository which is just cloned. So now I want to make my first code, then I want to commit those files to the repository. How you can do that? So either you can modify the existing files, or you can also create a new files and add that one. So to do that, first of all, I create a new file, which is say index.html is my file. So I'm making some code command here. Let's say I'm making some command like HTML is my command here, and let's say I'm making the title welcome to tech ARK IT is my title, and I close the title here. Now I make something like header h1, say welcome. Now close the HTML tag. So that's the simple code. I have a 4 lines of code I have here. It's not match. Now save by pressing the colon, shift colon, and WQ in VI editor. So now my code has been just uh, created here. You can see that I have created index.html file. But whatever you do, file changes, adding anything, so the Git will keep on tracking your changes. So to check that, you can say Git status. Now you can see that the Git is make some index.file here. You can say that this is an untracked file. Untracked file means that file is not in Git. It is not tracking its changes it anymore. Now, so to do that, adding that file into the Git tracking, then what you have to do is that git add and dot. So, or you can also specify the file name, so it will add that into the Git. Now, if you say git status, it will give you that the new file is had been added to your Git. Or if you have multiple files on the same location, you can say git add dot, so it will also add all the files into the Git. So now what I did is that I have added the new file which are ready to commit. I have made my first code file index.html, and I have written some HTML page, and it is ready to commit on the web. So to do that, committing the Git, so what you have to do, so git commit -m and provide the message. So what is the message which should be meaningful, um, and what is the action should be defined. So what it is, the commit is for what, so it should be defined that action here. Let's say adds index.html file to code base. So that is my message to the, or maybe you can simply specify that adds index.html file. It should be in future tense. Now I have made the change. I can see that the file has been changed and it is committed to the main, and it has some unique hash value and adds to the file, and one file changed and 4 insertion has been done, which is created the index file. Now if you go to the git status, so everything is clean. You have the commit has been completed. So now you have committed your git commit to the Git repository. So to do that, check that git log. You can just type the git log. So now we can see that which has the information about your git commits, what is done. So git commit, which is done, you can see that head is pointing to the main. So whatever the new commit you are going to do, it's going to here, and author of that code who made the changes, which is this guy right here, then adds the index.html file. So he added the new file here, and the commit ID is this one. So it has a unique value of that commit, and where he is added to the main branch origin head. So that's where which is added, and the author of that one is going to be this right here. Okay, so it has the unique value and is did that initial commit. So that's what happened. Now if you want to push this code to the remote repository where we have created the GitHub. So all the changes has been made here, but we don't know what exactly here. So if you refresh this one, the code is not came yet here. So there is no new file. There is no changes to this one, right? So how we can push that? So you can see there is only single commit, which is a initial commit we made here, but there is no commit has been done. To do commit, so what you have to do, so in between your laptop or desktop, then you have to have the connectivity between your GitHub and here, and it should be a authentication, or it might be a key based authentication, or the passcode or personal access token, all this stuff, right? Let's jump into the workflow first, how it actually works, then we can jump into the push and uh, push the code to the remote repository. So let's understand the Git workflow, how it do the code commit and code push, all this stuff, right? So what you have local laptop where it has installed the Git. So we just installed it, and where we have the remote repository, which is on a Git provider, in this case GitHub, right? So what we are doing right now, so we created the initial working directory. So we did not basically initialize the working directory, but we actually cloned it. Clone means you created the directory, and which is already have the Git information in it. So the repository is already initialized on the GitHub. You just clone that one. So now you have a working directory over there on your laptop somewhere on the directory. Then it has some staging area. Staging area means what? So example, you have created the index.html file on working directory, but you did not added that anything anywhere or trackings untracked file. That's what initially created your working directory. That's in a untracked file. But if you want to do to the staging area, you wanted to move to the tracking into the Git. So what you did, git add and file name. Then it makes your repository added into your staging area. So where you stage all the files. Now, once you do the git commit and provide the meaningful message to that one, and it commits to your local repository. That's where your local repository has been completed, which means that you have created your working directory and working space. There you have initialized your Git repository. Then you went ahead and added that to the staging area. Then do the commit to the GitHub. So which makes your local repository complete and clean. So you have done the commit. Now you have the remote repository where I have to push the code. So how you can do that? So before that, so what it do when you do the commit? So it basically makes your commit ID. That's a unique commit ID. Just we saw that while did the commits. Then it makes some commit ID, unique commit ID. Then who issued that commit? So who should that committed? Who is committed? Means who is the user? We should blame him, like if what he is committed to. That's called as a blame database. Who is committed? What he committed means what change he done, and what is the timestamp when it done. So when he committed the change. So this all has been carried over the commit when you do the commit. So it actually records the commit ID, the unique commit ID, and who done or who is committed that one is username. If you do not have any user information to that, it does not actually do the commit. It gives you error, meaning that you need to configure the commit who's the responsible person that for this commit. You have to make that change. Okay, so let's see that. We'll see on that one in a minute. What is committed? So what is committed? You make some index.html file and you written 4 lines of code, and when you commit it, so it's a timestamp, date, time, and all these seconds and everything will be do this time stamping. Then it actually commits the information to that commit. Now, so if you want to push that code to the repository, if you want to update that one, so either you make the two connections, either using the HTTPS connection or SSH connection. From your local laptop, you have to have the SSH connectivity to the remote repository, or HTTPS. Via HTTPS also you can make that one. So how you can make that? So you have to do some authentication mechanism to the remote repository. So what is the authentication mechanism you make here? So either SSH pair of private and public keys. So you have to generate that public key here on your local laptop, and you can authenticate that public key on the remote repository. Then you can do that. Another thing is that personal access token. So while installing on the Windows, I show that credential manager. So that's where you can use this personal access token and store that personal access token for a temporary access purpose. Example, this access token is very secure. It's only generated once time. Then if you capture that token and you can integrate with any of the your code application, example like Visual Code, Visual Studio Code, then you can integrate that with the credential manager. Then you can define that policies, like how the user can access, how many days user can access, what the user can do, example creating repositories, committing changes, merging, all this stuff does he do. So you can define that permissions on that particular token access while generating that one. So no problem, I will show you where you can do that one. And another one is credential manager access. So that's where you can store from the application and do the commit. So now where we are in this stage, a local laptop stage, where we have created our working directory, added the staging area, and created the local repository. Now we have to commit to this one. So to do that, we have to make the connection between that remote repository and local repository. So either we have to create SSH keys and make that possible, or you can also use the HTTPS access to make that possible. Let's do the step and commit the code. So now what you can do is that you can just say git push origin main. So this is the main branch. I'm pushing the remote code and enter. Now basically it will check for that and it says that you code base permission denied, you don't have any access to that one, unable to access the this code base because you don't have the access. You have to do the mechanism to access that one, right? So first what you have to do, so either you have to integrate this one within a personal access token or SSH keys. So let's see first of all how we can do the personal access token. So I'm here on the GitHub. So let's go ahead on your profile icon on the right side. You can click here and go to settings. Now you can see here this is your profile console, and you can just generate the personal token access from here by going into the developers settings here, developer settings, and you can see personal access token. Or you can also use OAuth apps, and you can say register a new application. This can also be done here. Or you can also say uh, personal token access token here, and say token classic. Say generate a personal access token here. Now write the information what you want. So might say Ravi authentication from the desktop Windows, right? So just make that one. And what is the access you need to have? So you have to define that one here. Then, so example, this one, git one deployment, git invite, and if you want, say, read user access, anything from here if you want to make that one, but as of now we don't want anything here. Let's say this is the one, yeah, repository and user access, that's what we need, and say generate token. So now copy this token value and go back to your console, and I can see our code has been pushed successfully. You can see that credential manager is not a git command, but you can see that this is the command which is actually add your remote repository with the code base. Then if you go ahead and see your repository code, right, and refresh this one, you can see index.html has been, you can able to successfully push that code to the remote repository. So that's how you can push it from the access token by specifying the git remote set URL. This is the command. You can specify your username here, code base, and your personal access token here, and github.com, and your repository which you are trying to set that origin. Then I said that git remote origin, here this origin name is the origin. You can change it to anything, but default should be fine. And in this origin is main is a branch name. So I push that code to that main branch, and you could be able to see that now the commit has been successful, and you could be able to see that commit here, right? So that's how you can push the code to the git using the git bash from the windows. Now let's go ahead and see that how you can do the same code push from your Linux machine or using the SSH keys. Okay, so what I'm doing here is that I'm just logging into my Ubuntu desktop. So this is my Ubuntu machine here. um, so now what I'm going to do is that I'm just going to create a or maybe I can just clone that one later on to commit the code here, but I use the SSH pass. Okay, so let's do that here. SSH key gen -t RSA is SSH keys I'm generating here on my Linux machine, so it will generate the keys here. For this one, so you'll have the ls-la and .ssh is the directory where you will have these files id_id_pub. So you need this public key to in order to have the SSH authentication. So let's get this file first. SSH id_rsa.pub and copy this public token from here, right? And copy this one. Now let's go back to your browser where you have your GitHub is open, and go to your profile and click on the settings. Here you can see that SSH and GPG keys. Let's say SSH keys here, say add new SSH key. Now paste that key here and say it is from my techarkit Ubuntu machine. So that's the title I just gave it here, and authentication token here. Now add the SSH keys. So now I have added the SSH keys and my Ubuntu repository is accessible from here. And let's go here to my profile, and what I'm going to do is that I'm just going to make this repository. What is the repository I have here? My web app repository. I will clone this repository and commit the changes to this repository from the command line from the SSH. So go to this SSH and copy the SSH URL here, and now go back to your Ubuntu machine and say git clone. So what I'm going to do, I'm going to make maybe I don't need to make any directory here. I'm just cloning that directory here and say git clone and paste that URL and enter it here. So it says my web app already exists. I'm just going to delete my web app here. Now again I try to reclone that one. So now for the first time it will need to accept the fingerprints. Say yes, and it's permanently added to your repository. Now you can see that my web app repository is ready here. Now if you see your index files are there, like what is the content you have written, and you can see readme file also is here. Now what I'm going to do is that I'm going to make some files. I'm going to add a new index new file here. Let's say touch let's say ubuntu dot html file. This is the file I'm going to make it on here, and I'm push it this one to the remote repository. So here I just say nano and ubuntu edit this file, sorry, ubuntu's dot file here, and say this file is from ubuntu desktop machine committed by Ravi. Now let's say save this file, and now you can see this one Ubuntu. Okay, let's rename this one the proper ubuntu.html, right? You can see that now file is there, and if you type git status, the file is untracked, so the file is not added to the git repository yet. Now say git add dot. So now see the git status. You can see that the git new file has been added ubuntu.html. Let's say git commit -m adds ubuntu.html file. Now I have made this one, but you see that it is asking me who you are. So it does not set any details here. So that's why you should set something. Otherwise, you cannot commit. It should not have any blame database, like it should not have the identification like who you are, what you are committing, all this. So in order to set that one, you have to use these two commands. Okay. So first of all, let's say git config hyphen global user dot email. So you have to use your email address here. Let's say my email address, I use it this one, right, at gmail.com, and git config hyphen global user dot name. So what is your username? I'd say code base slash Ravi. So this is my username. So now what you can do, you can run the git commit again. So it will say git commit has been complete successfully, and you can type git status, so it's clean. And if you type git log, it will says that you have the three commits now. So the one is an initial commit which has been done here from the while creating the repository, and this has been index that been created by the desktop machine, and this is the Ubuntu file has been created from the this here. So now what you have to do, so you have to push the code using the git push origin main. So now I'm pushing the code to the again main branch where I have cloned that one. You can see that now the object has been reused and has been pushed to the remote repository, right? So now what I'm going to do is, now I'm just going to see this code. It does not have an HTML here. Let's refresh this one. Now you can see ubuntu.html file has been committed, and this commit has been done. Now this has three commits. If you click on these three commits, it will give you the commit details, who committed and when they are committed. So you can see three techarkit has been committed around 37 minutes ago, and code base is created 48 minutes ago, and this file has been committed from code base Ravi from this one. So you can see these are all the code URLs which is committed. So now you could able to do your first basic commits from the repository, and you can use the personal access token as well as the SSH keys. Let's do something more and little advanced here, how you can make that progress. So as of now, we have seen that we have created the GitHub repository on the GitHub from using the web UI, like we logged into the web browser and created the repository, and we cloned that repository here. But if you are working from the base, like I did not have a account first, I did not created the GitHub or the Git repository first, but I wanted to initialize from my desktop or laptop first. Then whatever the code I have on my desktop, I wanted to push it to the GitHub, so that it should automatically create the repository, something like that. How you can create the any project name which you wanted to create on the GitHub. Example, I say that my scripting files is my repository name. I would like to use that one on the GitHub. So now I have created that one. You can just go to your scripting files location. So this is my directory. So if you just type it ls-la, it does not exist anything. So it does not have any Git like repository or anything like that. So if you want to make this directory as a Git repository, Git local repository, then you should have the .git configuration. So that is called as a .git file, which contains the configuration information about your Git. So in order to do that, so convert this directory as a local Git repository. So what you have to do is that you have to type git init. So git initialize, which means that so it will automatically initialize your directory as a initial repository, and it makes your directory as a Git. So you can see that using master, the name of the initial branch, the default branch name is a subject to change, configure the initial branch name using all. So I can change this something like that, git and config global init default branch and branch name. So namely commonly chosen is a master or main or the trunk for the development, or you can also use git branch -m name so that it will rename that branch. So in GitHub, basically they use main is in a branch name. So before it was a master, but now it is a become a main. So we have to change that. So in order to compile with the existing GitHub configuration, what you can do simply that git branch -m and say main. So it will make that main branch, so that the main branch when you push the code to the remote repository, so you should not have any issues. Okay, so that's the one. Let's say now we have initialized the Git repository, then we have to add some files, right? So what I'm doing is that first time I am adding the readme file .md. md is a special file for the Git repository to write the information about that one. So I say nano and edit this readme file, and I'm writing something like this, my scripting files repository. Okay, something like this, and say my first commit. Now Control X and save this file. So I have saved this file, and now you can see that Git status. So it is an untracked file because we did not added that to the Git. So it's a untracked file. Again, I'm going to create my first script. Let's say that hello world dot sh. This is my next file. I'm going to edit that one. I say hello dot here, and I'm writing this bash file, simple bash file. Say that echo hello world. So this is my just first code, and I say save this file by pressing Control X. Now what I'm going to do is that I'm going to add these both the files. Now if you see that, so .git is exist here, so which means the Git repository is tracking all the files which are currently on this particular folder, all the changes, and you have allo.sh file and readme.md file, right? So now say git status, so there are two untracked files. Now I am adding git add dot. So if you say git add, then it will automatically add all the files in that particular directory to the repository. So now you can see that there are two files which is in staging area. So the staging area of the files has been updated. Now what you have to do is that you can do the git commit and provide the message. So what is the message name? I say this is a initial commit. Initial commit. Now, so if you see that git status here, so now all is clean. So my git repository is confirmed that I have all the files has been added to the git. If you see the git log hyphen one line statement, now you can see that there is only one, and head is pointing to the main the main branch here. So we have the initial commit. Now see git log, if you see that, so it is the initial commit and all is clean, and it is there here, right? It is a initial commit. So now how we can push this code? this code to the remote repository. So what you have to do is that you have to go to that browser first, then create that repository first. So just a simple repository, do not add anything, initialize or anything, something like that. Then you can push that one. Go to the repositories and say new repository here, and create with the same name, like say scripting files, my scripting files, and just provide the my name, and that's it. I do not adding readme file or anything, just simply say create the repository here. So now it is asking me to follow this uh, to commit this data here, right? So I already done that one, right? So I already renamed that branch name, and initial commit has been done, and I have created the readme file and all this. And the next step is that you can add this remote, uh, this one, add remote on that, and you can push that code here. So let's go there now. Git, simply paste that command here, git remote add. So we are adding that remote as an origin here, details here. Now say enter. So now I have added the git remote, right? Now you can see simply git push, and you can push that code. So the same command is available here. You can see that git push -u origin remote, so that origin will be added permanently as in a remote. Now say main. Now the commit code will be pushed to the branch, like you can say that new branch main has been pushed it, and the origin and the data has been pushed to the uh, repository. So now if you refresh this one, it should be available your code. You can see that readme has been updated with your my scripting repository and my first commit. And if you see that the hello.sh, so this is also a file which is pushed out. So that's how you can initialize your repository, complete repository on your local, even if you don't have the Git direct connectivity between your remote repository and your local repository. So that's the distributed repository advantage. So you can create your local repository and work on. So once you're ready to commit, you can commit the data to the remote. But what is the commit information you have? You got it here. So it's got this code base dash Ravi, because so we already have that SSH keys enabled, that's why we get this information here. So otherwise you have to make some connection, like as it might be HTTPS connection, or the personal token value, or it might be SSH keys or anything. So if it is a Linux based systems also, that might be a SSH keys might be a easy, or if you already install the Git Bash, or you can also generate the SSH keys and push that to the remote. Okay, that's great. So what we have done, initial commit has been completed. We have successfully make the Git repository, and we have pushed the data over there. Multiple teams are working together. Multiple team members or the developers are working together. How you can collaborate? How you can collaborate to the multiple users? For example, multiple developers wanted to commit the code. So how we can do that? Create some branches and push some code, and we see that what is that fast, then we'll understand how the collaboration works here. So now let's say grid branch. So you can say that now you are at the main branch. Now I'm going to create the new branch, might be like git branch, and say might be anything. It might be bug fixes, or might be features, or it might be the uh, different stuff, right? A hot fixes or whatever it is, you can make that branch here. So for example, I'm making that is a features. features is a branch, or feature 1 or feature A might be a branch, something like that. So, so standard, I'm saying that feature 1 or feature A would be a good option. Like features might be a branch. I would like to mention that one now. So I have made the branch, the new branch. I am switching back to that branch. So to switch that branch, what you have to do, git switch and provide the branch name. Or you can also use git checkout features. So either ways you can do the value. Now you can see that switching the branch to the features. Now if you type git branch, you can see that now before it was at the main, now it is at the feature. So what I'm doing here, I'm going to make a new file, or maybe I'm going to make the changes on my existing files. Let's say in hello.world.ssh file, I'm going to make this like hello.world. I'm editing, and again I'm going to write is that something like echo added second line to the code. So now I'm saving this file, right? I'm again check that git status. So now that is file is been changed as a modified. Now I am pushing this code. So I will add it and push it to the remote branch. Okay. Let's say git add and say dot and git commit and say my commit message is that adds second line to hello world.sh file. Enter. Now I say git push origin features. So this is my branch. I am pushing the code. So this is my branch code where I am pushing the data, right? Enter. Now you can see that it's pushing the data to the branches. So you can see that this my script files, there is a new branch and it pushed the data out there. How does it work? So how does it work? If you just go here and see that, you can see that feature had a recent pushes. If you see that there is a view all branches information, you can see that there is a features branch available here on the branches. But if you go back to the code, you see that there is a compare and pull. Compare and pull had a pushes 1 minute ago. So now if you compare and say pull request, so it is taking the information, like you can say that what it is doing now. So example, if you say I already committed the data here, so it already went to the branches, right? But before I merge the data, before I merge the pull request or anything here, if I go to hello.sh, did you see any line here? No, right? New line is not added yet. The second line is not merged. But where is this new line is located? If you go to the features branch and if you see the hello.sh file, so you can see that that is a code second line is available. Okay, so now you see that compare and pull request. See compare and pull request. So now it is indicating that what is the change has been made, showing the change has been made. So this is the new line has been added. The plus means added. If you say, if you see the minus, which has been deleted. Okay, so this is the comparison of the previous and the current file version, and this is has been added. So there is no deletion on that file. So do you want to create the pull request and push that code to the main branch and merge it? Okay, then you can do that. So that's the what it is showing. So it is saying that features branch, so it is pushing to the main branch. If you say that it is ready to merge. So yes, it is ready to merge. It does not have any conflicts here. Let's say create pull. Now you can see that the pull request has been created and it is ready to merge. If you say merge pull request and confirm the merge, now the code has been merged to the branch. So now it is asking me to pull the delete the branch. If you want to delete, you can delete the branch. So the feature branch has been deleted from the branches list. But as of now, I am not doing. So let's show you a more example over there. So now if you go to the main branch and see that the code has been committed, right? So when this branches has been useful, so how the branches has been useful to the developers, or how they can collaborate here. Okay, let's see some discussion on this one. In DevOps world, how does it actually do? So where exactly the branch scenario works and the major um, for the branch uses. Example, so you say that your main branch is this one. So the main branch is this one. So you already have some 4 commits here, and these branches from the development to the production, which is connected on the continuous integration. So it is the main branch is connected to the pipeline, the continuous integration and the continuous development and the continuous deployment process. So once the you commit the code here, then it will actually goes directly to the production. So it compiles code and verifies the code verification checks and do the test and commit to the actual production and packaging and push it to the um, your production, right? This is connected, but I don't want it to directly do that, because without doing validating that code, like if I wanted to push it to the production, so before that I have to check the code integrity, how the code is written, and I have to do some testing and how all the worktions are working fine or not, and do that. Then I can merge that code to the main, then it will do the remaining stuff and push it to the production. But before that, if you want to push it, then all the developers, they cannot directly push the code to the main, so that the ultimate production will be messy, because some code might be the not secure, some code might be not tested properly, or some features are not testing, and pushing to the production is not a good practice. But implementing the feature is good, but without testing or without how it is working, without UAT, then user experience, then if you push it to the production, your users may face the issue that it might be a sometimes good experience, it might be a bad experience, but sometimes production may go down due to the some issues on the code. So that is not at all required. It might be a dangerous scenario that you push the directly go to the main and push it. One thing. Another thing is that so where so many developers are working, and so many developers write the code in their own style. So some of they write their pretty standard way, some write looking at some of the code reference and make some changes and write the code. But you cannot directly merge it to the golden image. Like this is example, your main is in a golden branch, then you cannot directly push it over there. So when you should push the code, there would be a ultimate check. So there would be a check in between before merging the code to the before accepting the code to the main branch. There would be a check. So how you can do the check? So you have to make the multiple branches under the main, like example bug fixes, hard fixes, features, and development code, so many things. Like based on your project name, you can make number of branches. Then the developer, what they do is that they push the code to this branch. Example, in our case it's a features branch. So I have developed one feature and pushed it here. So what happens whenever you create the branch? So the entire main branch will be cloned here. So the main branch of this one entire will be cloned here From here, you can make the changes. So until this code, like 4 commits, if you make the branch, the 4 commits has been until it would be same here, then there would be a fifth commit. So in fifth commit, I push the new feature, then it goes here. So here, what we can do is that we can write the rules. We can write the rules. If someone is contributing the code, then we make sure that they should create a pull request. Then the pull request, if the pull request is okay, there is no code conflict. Example, you already written the code, then they modified something. Then if you push to the directly, so there will be a conflict. But without conflict, if you want to accept it, so you have to first verify the code, what it is changed and why what is the reason to the change and what it adds to the main software. Example, what of the software you are developing, what it adds. The example, the code is valid, whatever it is, you have to validate before merging to this one. Then you have to validate here, so there will be a validate result or manual validation, whatever it is. Then the validation has been done, then you can do the merge using the pull request. That's how the merge completes here. From here, the merge goes to the actual production. Actual production. That's the branching requirement. Let's see. So what I'm doing is that I'm just going to create a new file. I might see index.html is a new file. You just edit that file and add some content to it. Okay, maybe I say testing file. Let's say save this one. Now git add, and I'm adding. So git file has been added, working copy has been created. Now if you see the git status, it sees that the file has been in tracking mode. So it is in staging area. You realize that this is not the file I would try to add. I want to remove that one from the staging area. What you can do is that, so you can use this command git restore -stage, and which file you want to remove it, then index.html file. So that file has been removed. Now if you type git status, the file is in untracking state. Now what you can do, you can remodify that file. Now save this file. Now you can add that one. So now I added the file to the staging area. Commit that message. Git commit -m added new index.html file. I have added the new file in and committed this one. So if you see the git status, right, it's all clean. There is a commit message has been done. Now if you see the git log -one line, so you can see that, and adds a new file into the index.html file into the git is already committed. So at this time I realized that, okay, so I need to do something. So this commit is not completed yet, but I need to do something. I wanted to revert that back. How you can do that? So you can simply do that git reset head pipe 1. So what you can do is that you can simply reset the last commit message, or you can also provide git reset and the commit ID, previous commit ID also you can do that. But it's only single commit. I wanted to revert back to that one. So you can see that. Now if you see the git status, so the index file has been removed from the commit, and it's came back to the untracked state. So now again what I'm going to do is that, okay, and right now we did that file and add some code correction example here. This is my code correction. I wanted to do that. I now add it manually. Now I can do that message here. Now let's try to push this one, origin main. So now I have pushed this code to the remote repository and my code is on the remote. Okay, so that's how you can restore or the revert back your changes. If you go back again, see that git log --- one line statement. So you can see that there is no added new index.file is exist here, right? That is has been removed, that change has been reverted back. So when you revert back, what it will do is that it will add actually the removal message if you already committed that one. But we did not actually push that to the main repository, but we have committed to the local repository and we changed that one. So now example, see here, you are working on something like example, you're working on some new feature development and all. But all of the sudden what you got it something like you got some bug on the system, you have to develop some hotfix. Okay, so what you can do to the existing code, how you can park existing code aside and you can develop working on the and that hotfix. So that's a immediate bug you need to fix on the production and that should be delivered something immediately so that you can park your existing code aside, right? So you can also do something like existing add or commit the changes, but that is a dirty one or it's not completed yet or you need some reviews and all before committing that. So all of the sudden you wanted to do that. So how you can do that? Let's see. So what I'm doing here, so I have the two files um, and I will create a new file. Let's say touch. I'm working on the new feature example, new feature dot html. So that is my new feature dot html I have created, and let's say this is a new feature file, right? So now I have created the file git status. You can see that it is untracked status. And now maybe I can add this one. I have added this data, but all of this sudden I wanted to add this data aside. Like I don't want it to basically push it. So I just park aside of this one. So how you can do that? So what you can do is that you can use the git stash. So which is a command, basically use your existing work and you can save that working directory and index state, which is in a work in progress, to main as a commit message. You can see that this is the commit message, added a new index.html file. So now if you go and do the git status, you can see that it's completely clean. So but before that it was, there was a new file into that staging area. But now what happens? It's clean, it does not have anything. So what you can do now, you can simply develop that one. So you can see that the file is also not currently exist. um, to verify that one, what you can do is that git stash list. So what are the stashed files are there? So you can see that. So work in progress to main, and there's the commit id, added new index file, right? So that is the last message which is actually stashed it. And you can also use the git stash show, so it will give the detailed information about that one, what is that file and all, how many insertions are the, how many minuses or deletions are there on that particular file. It will give you the detailed information about that one. If you want to example bring back that one to the your working directory, how you can do that? So you can simply do the git stash pop. So it will pop up that one, and it will actually, you can see that dropped references stashes, and it is has been reverted back. You can see that the file is here. So before there was no file. If you list this one, there was no file, but where it went, so it actually racked somewhere else. It sparked somewhere else that code. Then whenever you are do the git spap git stash pap, it will actually coming back here. So you can see that that is a new file added to the staging area. Now you can do that modifications and add that and commit that file, right? What you can do, so git commit -m and say added new features HTML file. Now that's commits the information. Now you can do the push um, origin main, so that pushes the new feature files to the main branch, and you can see that now git log -1 line information. So many changes has been done as of now. So many commits has been done, right? That's how you can actually stash it. Stashing means you can do the work aside, keep the work aside. If you get something new request or anything, then you can work on that request. After you worked on that one, what you can do is that you can bring back that code. Okay, let's understand what merge and rebase do here, right? So how the merge basically works and how the rebase works. So if you want to do the merge, if you want to do the merge, like apply the changes from one branch to another branch, one can use merge command, so that you can do the merging of the code from one branch to the other branch. We just now see the example like how you can do the merging from the bug fixes branch to the main branch, the code has been merged by using the pull request creation and all this stuff, right? So in the rebase, this is an alternative to the image commands, should be used on the local branches to avoid the confusion. So why we have to use local branches instead of using the remote branches? So that's an example. I will tell you how to use that and all. Should be used on a remote branches since history does not change for the merger, right? Merger creates a new commit, which is a merger of the two branches. So if you merge like git merge and use the merging option, then it's basically use the another command, like the another commit ID says that this is the merged pull request, something like that, right? On the rebase should not create any new commit because it does not actually do the any new commit, and results a cleaner history. So how you can use the git merge? So git merge is something like you can use the git merge command, like git merge, and provide the source branch. So it merges the source branch, the destination branch into the source branch which currently you are in. So or you can provide the branch name so that it bridges the that information, right? In the rebase, the destination branch commits is pulled from its base and rebased on the latest commit on the source branch. So that's the meaning of the rebasing. So but let's see some example here graphically how basically does it work here, right? So merge, if you example see that, take it as a main branch. In main branch you have something like three commits, like 1 to 3 commits, right? And the you have a branch bug fixes, so where you have cloned that one, created a branch and at this point, and it has a one more new commit to the bug fixes. So when you do the merge, what happens? So when you do the merge, so it's basically creates this commit will be pushed out to the main branch, and bug fixes will go on changing that merges, the whatever the code you have, it keep on going, right? So do the merges and it creates the commit ID over there. But in rebase, what happens if you have the similar structure, like you have the main branch and you have a bug fixes branch created, but when you do the rebase, so what happens? It cleans up the every history, right? And the branch commit is pulled from its base and rebased on the latest commit. So whatever the latest commit has been there, so it's just uh, commits on the source branch, something like this. So that you don't have the multiple histories like similar commits, so those are merged together and rebased, right? Means like those are basically combined as a single commits, and it makes a cleaner combination, right? When you should use basically merge, and when should use the rebase. So if you are working within a larger community, like the larger developers community, and which is involved more than a 5 members or more than that team, then use the merge. Always is a good option, that what is committed and what commit history you have, so everybody knows when it is what changed and when it is changed and who changed all this information. So it does not basically write or do not create the confusions to the larger developer infrastructures. But if you do here on the like the rebase on the larger population, example, if you have the 10 to 15 developers, then you do the rebase, then there might be a loss of history, because it makes it clean to avoid the confusion or having the larger history on the rebase. So the rebase is basically works when a single developer or two developers or three developers working together, then they would like to have the cleaner history, the thinner history on the commit history, depends. So that's time what you can do is that you can use the rebase. Okay, let's dive into the practical and simulate this, how you can do the rebase and merge. So I'm going to create a new um, repositories, like for one is for merge and another is for a rebase, and see how you can basically how they looks like after the doing the rebase and the merge. Let's do the practical on merge and rebase. So here I'm going to create the two repositories. One is in a merge demo, which is in a repository we use for the merging example. And another repository I'm going to create is that rebase demo. So which is used for the how the rebase looks like. So that's for the rebase demo. So there are two repositories. One is for the merge demo and another is for a rebase demo. So that's the two repositories I have created. And so I have opened the two Git Bash windows. One is for the merge example. So that's the merge I'm going to use over there. And another window I use for the rebase. So let's say I'm going to create a new directory which is merge dash demo. And here I'm going to create the new directory called rebase dash demo for the rebase purpose. Let's do the cd into the merge demo directory, and here I do the rebase demo and initiate the repository by using the git init. So it will initialize the empty git repository here, and I create the new file which is called readme.md here, and add some text to that one, and initial commit, we can do this initial commit to the um, repository, so that we will have the initial information. um, it's called as welcome to readme file, something like that, right? So again, send that message also here into the git add, and git message is added here. and do the git add here as well. So git add I did not give in the space. Okay, let's redo that one again. But do the initial commit here on the merge, um, and try to commit here, but it does not go well because the git add does not have the space. Okay, so let's add that one, git add dot, and do the git commit. So now both the repositories are this similar level. Um, and to push this code, we need to add the remote. So first of all, you need to I just create the branch here, and here also I create the branch, like a git branch bugs and git branch bugs here. And if you check that branch, so I'm into the main branch, and here also I'm into the main branch. Now I can create the push, or you can do the checkout and do the another file and push it. But before that, I just do the push. So to do the push, I need to add that remote origin information here. Let's copy that and paste it over here, remote add origin, and now push that code to the main branch and git push origin main. So the merge demo code has been pushed to the remote repository. I now go back to the Rebase demo and copy that URL and paste over there, and do the push, git push and origin main. So now both the repositories initial push has been completed. Now let's do the check out to the bugs and do the new file and push that one. Git checkout and do the bugs branch. Now touch, create a test file here, and create the same on the this here. Sorry, unfortunately it selected all the things. Just do the ignore and clear the screen, and just do the touch test file and add some message to that file. Let's say test file, something like that, and redirect that message to the test file, and copy this again, paste it on this window so that it will have the similar message here. Now do the git add, and here also you do the git add, and you can commit that message, commit that information, git commit -m, add a test file, and you can also do the same thing here, git commit -m, add a test file, a similar message. Now push this code to the bugs branch, git push and push it to the bugs branch, and here also you do the similar stuff, git push, sorry, it says punch, but it should be a PUCH, the spelling mistake, origin my bugs here. So I push the both the repositories in similar way, and if you go back and refresh that repository, you can see that there is a pull request. So here, while doing pull request acceptance, so one we are going to do the merge, another we are going to do is a replace. Okay, so now create the pull request here, and you can see that there is going to be the verification, and do the merge and confirm the merge. So now merge has been completed on that particular branch, merge demo. And if you go back to the rebase demo here, and again you see the same pull request here, and go to the pull request and create the pull request. And here, while merging the information, so you just do the rebase and do the merging. Now, now do the rebase and merge, and confirm that one, so that it do the rebase and match. So it's little different between the history commits on the merge as well as the rebase. And now let's go back to the command line and see how it looks like, right? So do the git bull and update the main, because what is the commit has been done on the main, it will be pulled on the local repository so that it would be up to date with the remote repository information, right? Now you can see that waiting for the editor. So the editor will be open on a separate window. So you have to basically do that any message to that. Now verify the git log with the one line information. You can check that what is the git information looks like here. You can see that. And here you can check that same message like git log one line message, how it looks like. You can see that there are the in the rebase there are added test file has been shown 2 times, but if you see on the merge, it looks like there is only a single merge. How we merged that one, it shows similar way, but in a rebase it looks different, right? So that's the difference between the rebase and the merge. But if you see the a graphical git log graph in a pretty line, so it shows that how this git merge has been committed. You can see that how it keeps the history. And if you do the same command here on the merge, you can see that how it looks like on the merge, right? It's quite different, right? So it's try to merge rebase, rebase it try to clean that history and do the single stuff, but in the merge how we committed it's do the similar way to merge it. Okay, let's see some special files here, which is a dot gitignore and dot gitkeep. So what they actually helpful and how you can use them in Git. So example, this is my Git repository currently I have, and these are the files has been committed, right? And if you see the git log hyphen in one line message, so these are all the files has been committed to the Git repository, right? But example, so what I'm doing is that while doing the code, I make some build directory or some logs directory, so and so. Then I don't want to track of them, or I don't want it to commit them into the actual Git repository, because those are the log files and some secret files and all this stuff. I don't want it to track them. I don't want to commit them into the Git repository. So to do that, what you can simply do is that you can simply create a dot git ignore is a file. You can just create this one on the main git repository directory. Then you can specify that here which files you don't want to track it. Example, I wanted to do not want to track slash build directory or any log files which is start with the log, like a regular expression also you can use it, or maybe you have some local configuration files or anything you wanted to don't wanted to commit or don't wanted to track here. So what you can do, maybe you can specify that I have a sensitive files which are text files, information files. I don't want to track all of them. So you can add them into the dot git ignore here, example. Then if you create any new file here with that name, like example, say messages dot log. So then if you see the git status, so then it just ignores those. So you can see that those are the messages dot log file is here, but it is not added to the Git repository. So that's how you can make the git ignore to ignore the certain files. Basically, you have some prac ground, like where you log the messages, or you temporarily create some text files or something like that, or the secret keys or anything, then ignore them so that you won't add into the git tracking details, like that. So example, if you create like mkdir, I created a new file, example, that is my data directory I have created here. If you see the git status, then it says that it is not added because the empty directories are not in a Git because it simply ignores the empty directories. Or if you want to keep some structure, example, my softwares required some structured information, like within the data directory I should have some predefined directories, then it should be in repository. Then in that case, what you can do is that if you simply go to that directory and create that dot git keep is the file, you can just create that one. Now if you say git status, it simply add that git file to the location basically. And if you commit that message like a git add and dot, and if you say git commit -m, example added new git keep directory or data directory, uh, then if you push that git push origin main, then the directory will push into the remote repository, and you can visit that and refresh this one. You can see that data like this one, right? So what you can do is that, so for the keeping the files, if you want to structured data directory structure, which might be empty, but you need that structured directories within your software, then what you can do is that you can simply specify that dot git keep, so that it will keep that empty directories as well also into the repositories. And you can specify dot git ignore and specify the files which you don't want it to track by the git. You can also do that, so that way you can ignore the unwanted files or the not required files to the git. And you can use the dot git keep to the keeping the directory structure or the required files into the repository. So that's the major difference between the dot git and the dot keep, git keep and git ignore. So this is not documented anywhere on the git officially, but those are the useful files. You can use it when you want.